Okay, in this video we're going to be having a look at question number 5 from the WJC Additional Maths paper from June 2014. It says, given that y equals x squared plus 8x, find dy by dx first principles. Okay, so first principles is a relatively simple question. You need to follow a formula. So the formula is, let me just write it down up here, dy by dx equals the limit as h goes to 0 of f of x plus h minus f of x all over h. Now, to start off with, I'm going to be focusing on this bit in brackets. I'm going to ignore the limit and I'm going to deal with the limit right at the end. So I'm just going to deal with what I need for this expression. Now, the beauty about first principles is because your differentiation skills should be strong enough that you should know the answer to this derivative anyway, so that dy by dx will equal 2x plus 8. So we should know what the answer is going to be. And if we don't get that, then we know we made a mistake. So let's see what we got. So we already have our f of x. So our f of x is the function we've got to start with, which is x squared plus 8x. Now we're going to find f of x plus h. So all that means is that instead of substituting x in and getting x squared plus 8x, we're going to substitute x plus h in. So I'll have x plus h in there and x plus h in there. So I get x plus h all squared plus 8 lots of x plus h. Now if we expand these brackets, the first bracket is a bracket that is very common in first principles. So your best bet is to learn how to expand it quickly. So square the first, x squared. Double the product. Well, the product is h times x, so that's 2hx. And square the last, so h squared. Then you have plus 8x plus 8h. So this is fraction. So that's my next step. So f of x plus h, I'll just use the right colour. So f of x plus h minus f of x all over h is going to be x squared, so my f of x plus h first, plus 2hx plus h squared plus 8x plus 8h, and then I need to subtract all of my original function, which is x squared plus 8x, so I put that in brackets because I'm subtracting the whole thing, all over h. Now if I've done this correctly, everything in the bracket should cancel out, so x squared minus x squared, they will cancel, and we've got an 8x minus 8x, so they will cancel. So that then leaves me with 2hx plus h squared plus 8h all over h. I'm running out of room, so let's see if I can sneak this in. H is a factor of everything on the top, so h lots of 2x plus h plus 8 all over h. So then we have a multiple of h on the top, and we're dividing by h on the bottom, so they will cancel, leaving us there with 2x plus h plus 8. That then can't simplify any further, so that's this now is the simplest version of this fraction that we had up here. Now I have to deal with the limit. So I can say, therefore, dy by dx, so the actual gradient function, is what we get from this expression as h goes to 0. So let's see what happens to each term as h goes to 0. Well, the first term, 2x, doesn't involve h at all, so h going to 0 doesn't make a blind bit of difference. The second term, plus h. Well, if h goes to 0, h plus h is going to go to plus 0, which will cancel. The third term is plus 8. Well, that has nothing to do with h, so as h goes to 0, that's what we said we were going to get originally.